So what I wanted to make sure I covered in this is both the dev and the ops side of DevOps. And I'm going to be doing this by talking through a real world example that we've been working on here at Sitecore. And we learned heaps along the way. So that's basically what I'm going to be covering today is all the learnings out of that project. So to look a little bit behind the scenes at the technical marketing department, well, we're responsible for a whole bunch of different sites. The main ones I'm going to be focusing on today are the MVP site and also the various different subcon sites that we have. And if we look at how these were hosted previously, they were split across two different Sitecore instances. So we had an older V9 instance hosting a few of the subcon sites and also the portal that we use to manage the review process for the MVPs. And we also had a newer 10.2 instance that hosted the main MVP site and also the application process for the MVPs and the subcon EU site. Now, having our site split between these two different instances, it led to quite a few issues. And some of these, they're going to be pretty familiar for anyone who's working customer side, talking to people, building with Sitecore. It's a lot of the issues that we hear about pretty frequently. Having two different solutions to maintain wasn't great. Having one open source and one closed source, the different governance models there also definitely added to the complexity around that. On top of that, managing two entire Sitecore XP instances left us with a lot of infrastructure we were responsible for. Not only were we responsible for managing it, but also paying for it. I mean, that was a huge expense it takes to manage all of, well, to basically stand up and manage all of the different infrastructure pieces. On top of that, upgrades were really painful. There's a reason we're still on version 9 for one of these instances. We were kind of partway through this migration that never actually got completed. So we wanted to solve all these problems. An XM Cloud came along, and it seemed like a really good platform to enable us to do that. So we sat down and we basically figured out what was our target setup going to be that had led us combat all these issues. And it basically boiled down to having a single XM Cloud instance that could power all of the different sites that I mentioned. And when I say single XM Cloud instance, we do have different environments in there, as you'll see shortly, but we're not going to split this out into multiple different repositories and instances. It's one XM Cloud is the way we're thinking about it. And if we manage to move over to this kind of architecture, it allows us to, first of all, unify our developer experience. It no longer means we're split depending on which site we're working on. We're working out of one repository in a mono repo style. We wanted to make sure we maintain the open source governance model. This allows us to basically use the source code we're building and the learnings from that to build out content exactly like this session. All of our team does a lot of presentations, a lot of content creation, and being able to work on open source projects like this gives us a lot of examples out there in the real world that we can refer back to. On top of that, the open source version we had previously, the 10.2 repository, we got a lot of really good community engagement from that. People logging issues, logging PRs, doing feature development, and we wanted to maintain that engagement with the community. So keeping open source for this was a big plus for us. One of the main things that we got out of this, though, was the ability, well, we had drastically less infrastructure to manage. And this was a huge win for us. And you'll see shortly just how smaller the infrastructure is compared to when we were working with the previous instances. And look, I'm pretty sure my manager will be happy with the smaller Azure builds on the back of this as well. Finally, having the updates handled for us by the platform was another massive win. It means we're not going to be stuck on an old version like we were with that V9 instance before. We're always going to be on the latest and greatest that XM Cloud has to offer. And look, I did include this last line here. It's underlined for a reason. This is not a starter kit. We don't want customers and partners to take this repository and clone it and begin their implementation with it, even though it is open source, it's out there today. That's not what it's built for. There's lots of basically specific functionality for the different sites themselves. It's there as a great example for how you can stand up sites, how you can deploy sites, how you can work with multi-site, multi-technology, multi-cloud, but it's not designed as a starter kit. So yeah, please don't tell people to do that. Okay, so I said I wanted to focus on both sides of the DevOps kind of coin, and we're going to start on the dev side. So what we really wanted to focus on with this repository was developer freedom. With this being open source, we wanted developers to be able to work the way they wanted to work. And to achieve this, there's actually a few different ways you can run this repository. First way we have to run the solution is to run everything local using Docker. And for anyone who's worked with Sitecore V10 in the past, this is going to be very familiar, especially if you've worked with it in Docker previously. Here we're running all of the required application instances locally in Docker containers. And it is lighter than running a V10 XM instance. There's less containers that you'd have to deal with on that side. There's no CD server, there's no identity server containers, for example. But it is still quite heavy. You need a decent specs machine to be able to run all of this, just as you would when running V10 Sitecore. Speaking of machines, you'll also still need a Windows machine for this, as we're still based on Windows containers. If you look at the diagram there, you can see the bottom row of containers, the middle one is the content management piece. That's still based on the .NET framework, which requires Windows, so Windows container, which requires a Windows machine for it to run on. We do see this, though, as being very appealing for traditional Sitecore developers, especially .NET Sitecore developers. But if you're new to Sitecore, or maybe you come from a JavaScript background, it might not be the way you're keen on working. So we came up with another few ways to run this repository, which can hopefully keep those kind of developers happy. And this involved basically not running a lot of these containers locally, but developing directly against XM Cloud itself. And here we're only running the heads, so the different site heads, and we have a proxy in front of them just so you can access them easily. But then we're interacting with XM Cloud itself to pull down our data. And look, there's pros and cons to this approach. It is super lightweight, so you can run on a much less powerful machine. Currently, a Windows machine is still required, but that's only because we're sharing these same containers from the previous slide. We do have an open issue in the repository to move this way of working over to use Linux containers. We just haven't got around to setting that up yet. It does work. One thing I really like about this is it provides a really easy way to test production issues. If you have an issue in production, maybe incorrect content being displayed, or it could be errors being thrown, what you can do here is you can basically take your head, point it directly to your production edge tenant, and run locally with live production data, stepping through the code, being able to instantly pretty much debug and see what's going wrong. Traditionally, that was something that was really hard with a non-headless DXP, because you'd have to do things like downloading database backups, and in some enterprise environments, that's not even possible to do with production data. So it's really nice to have this freedom basically provided. And look, working this way, we see this as being appealing for both JavaScript developers and .NET developers who want a much more lightweight way of working. But there is one other way that you can run this repository. And this is what we're calling edge development without Docker. And it's very similar to the approach we just looked at, but instead of running the heads in containers, we're running them directly on the host developer machine now. So if this is a JavaScript head you're working with, you'll be running it directly through NPM. If it's a .NET-based head you're running, you'll be running it through the .NET CLI or directly through Visual Studio. The pros and cons here are similar to before, but one of the big benefits you'll get is that you basically you don't have to have this dependency on the Windows machine anymore, because we're not in those Windows containers. We're running directly on bare metal. You can run this way anywhere you can run NPM, anywhere you can run .NET, and we're talking .NET 6 and onwards now, so it's truly multi-platform. So you can run this way on Windows still if you want, but you can run it on Linux, on Mac, on most of the major operating systems out there. So we've touched on our dev cycles there, and once you've done your development, you've checked in your source code, it's all gone up to your repository, you need to start pushing your code out. You want it to get to your live instances. So that's what I kind of want to talk about now. What we wanted to make sure with this project is that we were using the best tool for hosting. What does that mean to us? Well, it meant that we wanted to host our Next.js heads in Vercel. Vercel built Next.js. They're the primary hoster for Next.js sites. And we wanted to use Azure to host our .NET-based heads. Super easy to push a .NET app out to an Azure web app. So this is what our end architecture ended up looking like. And straight away, you can see it's so much simpler compared with previous Sitecore architectures. Really, all we're responsible for now is hosting the heads. And it's a couple of Vercel sites and an Azure web app. But that's all it is. Now, obviously, there's a bunch of instances and technologies hidden behind that XM Cloud icon here. You're talking databases, application instances, indexes. Edge itself is represented by that icon as well. Well, that's the joy of using the SaaS platform like this. We're abstracted away from all of that. We don't have to worry about any of it because it's all handled for us. All I need to be concerned about is getting my code and my content deployed out to that XM Cloud instance. And as it says in the corner here, if we need to stand up a new environment, we just have to replicate this same setup again. We currently have a production and a staging environment configured. If we wanted to add testing or QA or anything else, we just replicate this same setup again. So let's take a look at how we ended up automating this process. Well, we chose to use GitHub Actions to build this out, and that was for a couple of reasons. One being that Microsoft seems to be moving a lot of their development towards GitHub Actions, away from Azure DevOps. So it made sense for us to use this newer platform. Plus, we also had a full end-to-end Azure DevOps example in the old V10 repository I talked about before. So this gave us a chance to show how you can automate Sitecore deployments using a different CI/CD technology. And before I dive into this too much, I do just want to call out the out-of-the-box GitOps deployment that you get with XM Cloud. If your scenario is supported by that out-of-the-box GitOps approach, you should definitely use it. If you use the out-of-the-box scenario, it means you don't have to stand up all these deployment pipelines yourself. They're also constantly being iterated and improved by the product team. So all those iterations and improvements as they get rolled out, you get them automatically for free. So if it does fit your workload and your scenario, you should definitely go down that route. However, there are a few scenarios where you can't use that. The main one currently is if your source control repository you're using for your code is not GitHub. Currently, we're only supporting GitHub for that. We have others coming down the track. Azure DevOps and like are going to be supported soon, but we don't currently support it. Now we are using GitHub for our source code here, so we could have gone down the GitOps approach, but we wanted to provide an example for people who can't. So we've built up this CI/CD pipeline I'm going to talk you through using the Sitecore CLI, because that's the approach that people who can't use the out-of-the-box GitOps framework are going to have to go through. So what did we build? Well, we started off with a single pipeline, one giant YAML file that will go and deploy XM Cloud. It would push out our 2 Vercel apps. It would push out our Azure DevOps web app. And it did that for every commit to the repository. And it worked, it did, but it was so heavy. You know, if I'm making a one-line change to my JavaScript app over here, why am I deploying my .NET app over here? They're completely unrelated. And it was just blowing out our deployment times completely. It just didn't work for us at all. So it quickly became obvious that we needed to split out our pipelines by target system. That means we have a different pipeline for each of the sites we're actually deploying, and they're going to go out to the cloud that hosts that site. So we have a deployment that goes to XM Cloud. We have a deployment that deploys the MVP site out to an Azure web app, because that's built with the ASP.NET Core rendering SDK. We have pipelines that deploy the subcon sites. They're both built in Next.js, so both of those get deployed out to Vercel. We also have a series of reusable workflows that are basically there to power those different steps, and you'll see those in action shortly. Okay, so, the one other thing is how we decide when they run is with the actual commit. So when a commit happens, we check the paths in the commit for where the files have changed, and that is used to define which of these pipelines execute. Okay, so probably enough slides for now. There we go. Okay, so I've loaded up the repository here, and when you load it up, you'll see there's this .github folder in the root of the repository, and in there you have a workflows folder. And this is where your GitHub Actions templates exist. And you'll notice straight away there's a naming convention. We have YAML definitions with a build underscore, and that's defining basically a shared template for how to build a certain type of site. So it shows how to build a .NET site and also how to build a Next.js site. At the bottom, we also have templates prefixed with a deploy underscore name, and they're there to define how to deploy to a certain cloud provider. So it'll define how to deploy to an Azure web app. It'll define how to deploy a site to Vercel or how to deploy to XM Cloud. In the middle, you can see the CI/CD pipelines themselves, and they're controlling how these different sites are deployed, and they reference those different template actions. So you can see we have a pipeline for the MVP site. We have a pipeline for the subcon ANZ site, subcon EU. We've since added subcon events since these sites were built, and we have XM Cloud. And XM Cloud is where I'm going to focus today, because if you look online, there's a heap of examples out there for how to deploy a .NET app to Azure using GitHub Actions. The same for Vercel, but XM Cloud is the new piece. This is the interesting bit which people haven't been able to do before. So this is where I'm going to focus on. So if we load up this pipeline, this is what a GitHub Actions pipeline looks like. It's a YAML file. That's what all these definitions are built in. And the first section here defines when this pipeline is going to execute. The first one basically is a workflow dispatch action. And what that means is that when I go into GitHub in the Actions tab, and I'll show that shortly, it means I get a button there, which basically means I can manually dispatch this workflow, just manually kick off a build. If I don't include that, then the only type of builds that will happen will be automated. The next section says we're going to run this whenever a push happens into the main branch, or whenever a pull request is open that targets the main branch. So they're the other times this is going to fire on an automatic schedule. Next, we basically scan the paths of the commit, which is what I just said, that basically this defines when this action is going to execute. The first things we're monitoring are the actual pipelines themselves. You know, if we change how we deploy to XM Cloud, if we change how we build a .NET solution, because that happens in here, or if we change how we deploy XM Cloud, then basically we need to test those changes. So we're going to need to rerun this workflow. Next, we monitor the XM Cloud build.json. So when working with XM Cloud, this is a file that lives in the root of your repository, and it's there to control how XM Cloud gets deployed. So basically, this defines what the deploy app in XM Cloud is going to do. And you can see we have basically the first section is defining which of my items are going to be deployed. We're using items as resources to push all our code out, to push our content out, sorry. And you can see which modules it's going to deploy as part of the deploy app. Next, we have the build targets node. Now, I think a lot of projects probably won't include this. And by default, the XM Cloud deploy app will basically take all the .NET code in this repository and push it into the CM image. It assumes that that's what it's all destined for. That's not the case with this repo. This is a mono repo, as we said. We have all the heads in here. We have our MVP site in here, which is built with the ASP.NET Core rendering SDK. That's .NET code, but it's not meant to go to the CM instance. This build targets node allows you to define which projects specifically are meant to go to the CM instance. So we have a naming convention in here. Everything in a platform folder is what's meant to go out to CM. Next, we have our rendering hosts. So we have our Subcon ANZ rendering host, and we have our Subcon EU rendering host. The reason for this is that XM Cloud will stand up an instance of your rendering host internally within XM Cloud. This isn't designed to serve traffic externally. It's there to power the editing interfaces. So the experience editor, pages, components, that's the instance of the rendering host that's used to power all those WYSIWYG editing interfaces that we have. You'll notice, though, there's no MVP site in here. That is because currently XM Cloud can only stand up JavaScript-based rendering hosts. And as I said, the MVP site is .NET-based. So what you have to do here instead is stand up an external instance of the MVP site, which we have done. And then you can use environment variables within the deploy app to basically tell Sitecore where to pull in that rendering host instead. You still get your WYSIWYG editing, it's just you have to stand up the host yourself. The final piece here is the deploy actions. So this specifies what happens after a successful deploy has been initiated, or after it's completed even. So we're populating the index schema, make sure all that's set up. We're then going to do a reindex to make sure all the content's indexed correctly. And finally, we do a publish, so making sure all of the content changes have gone out to Edge. Okay, so what else are we monitoring for these commits? Well, as I said, those three projects, which are destined for the CM. So if any of the code in those changes, in those platform folders, we need to run a build, something's changed. Finally, also the items, anything in an item folder. As I said, we're using items as resources, so those items are going to get baked into that CM image as well. Anytime those change, we've got to push a build out. And you can see it's the same set of paths for both the push and the pull request. It doesn't change for either, it's the same kickoff paths for both. Okay, so we've decided when it's going to run. What actually happens when it does? Well, we get out to this job section here. It's going to go and it's going to run through these in order. So the first thing it's going to do is it's going to build the .NET solution. And here's where we start to pull in these reference template workflows we defined. The build.NET workflow, designed to build the .NET solution as part of this repository. And we pass in the build configuration. So we want to build this in release mode. So if we go and look at our build.NET pipeline here you can see the parameter we're expecting, the build config, and then it has its own job section. So you can see it's all quite nicely nested here. And what this is going to do is it's going to go and run each of these different steps. So we're going to run the MS, basically first we're going to do a checkout, sorry. Then we're going to run setting up MS build. After that, we'll install NuGet. Then we restore the NuGet packages, we run a NuGet restore. And finally, we do a build. And this is here to basically check that any C# changes that have been committed as part of the pull request, basically that they build, that they're functionally correct. You'll notice this is having to run on a Windows machine, a Windows runner within GitHub. And the reason for this is because of that dependency on the .NET framework we talked about earlier. Okay, so we've built the solution now. Hopefully it worked. Hopefully the code builds successfully. If it does, then it's going to move on to the next job in the list. And this is deploying the staging side. And you'll see we have deploy staging and we have deploy prod, and they're very similar. And that's because they're both using this shared template, which is deploying to XM Cloud. This is going to deploy to the different environments we have. You can see it has a dependency here. So it's basically set to run after the build.net. And staging is set to, basically prod set to run after staging. We pass in a series of different secrets in here this time. So a client ID, a client secret, and an environment ID. And also just a parameter with the name of the environment we're passing in. We do have a few if statements here. So we don't do builds if this is coming from an external PR from a fork, because they don't have any access to the secrets because it's a security risk. So that's why we don't do any builds with this if statement. And finally, this if statement here is checking whether this run of the action is targeting main. What that means is whether this is going to be merging into main or if it's just the opening of the PR. Opening of a PR from within the repository will go out as far as staging. It won't basically run the prod build. When that PR gets merged into production, it'll go all the way through and run production as well. So let's take a look in this deploy XM Cloud shared template too. And it's very similar to before. You can see we pass the secrets or define the secrets it's expecting. We define the inputs it's expecting. Notice this time it's running on an Ubuntu machine. All we need for this to run is .NET 6. That's what the CLI is built against. As I said before, truly cross-platform now. So we can run these on these lightweight, really fast Ubuntu runners, which is super nice. Again, this time we go and we do a checkout first. Then we're going to set up .NET 6 because that's the version it's running with. We run a .NET tool restore. And if we look in this config directory, we can see we have this tools.json. And this defines which CLI tool we're going to be using, which is the Sitecore CLI, and the version of the CLI we're going to be running. After this, we run a .NET help. And this basically initializes that, that Sitecore CLI command. If we look in the .sitecore folder, we have this package cache with all these different modules that provide the different functionality. Running that help command basically downloads those and initializes the CLI ready for us to initiate to basically run our deployment. So we're in a place to start now. We've got everything we need. So the first thing we're going to do is we're going to authenticate with the XM Cloud deploy app. And we're going to do that with a .NET Sitecore Cloud login command. Normally when you run that locally, it's going to pop up a browser. You'll put in your username and password. Obviously, you can't do that when you're running in a CI/CD instance because there's no user at the machine. So we do this using client credentials. If you go into the deploy app, you can generate a client XM Cloud client ID and an XM Cloud client secret, which will allow you to do that. Finally, we want to allow write because we need to basically make updates to the environment. After we're authenticated, now we can actually go and run our deployment. So here you can see we basically have this bash script which does this. And there's a reason we don't call the command directly. Well, the command itself is .NET Sitecore Cloud deployment create. After there, we pass in our environment ID, the environment we're deploying to, and then we use the upload flag. And that's going to tell it to upload this repository it just checked out, read the XML build.json, and act on that accordingly for how it's going to deploy its various assets. Now, for this bash script, as I said, there's a reason we don't just call this command directly. So it will return a response object, but whether that response is successful or failed doesn't indicate whether the deploy was successful or failed. It only indicates whether the command was issued successfully. So what you need to do is you need to basically output the result as JSON using this JSON flag. And then you can save that to a result object that you can query afterwards. And we care about two parameters in here, one whether it timed out and one whether it completed successfully. So then we can basically interrogate those values, and if it timed out, return an exit code. If it didn't complete successfully, also return an exit code. And if all of those passed, then we go down and we're completed. Okay, so kind of running low on time here. The last thing I want to do is hop over to GitHub itself and kind of show what this looks like in GitHub Actions. Here you can see again all the different pipelines we saw in VS Code. You can see which ones have been run here. So this is a Sucre EU run, this is an XM Cloud run, and these are merged into main. So these have gone all the way out to production. And I'm just going to quickly drill down into one of these, and mostly that where we actually deployed the XM Cloud app, where we went and ran that bash script just to see that in action. Here you can see, we ran our result, and we actually we echo the result JSON to screen to make it easier for debugging. But you can see timed out was false, and the completed was true. So look, XM Cloud opens up a variety of development approaches. You really can use the best development language or your favorite development language, or the development language of choice for your use case. It's really liberating in how you want to work with it. On top of that, it's a super simplified architecture compared to V10. So much more leaner application footprint than previously. It also opens up a wide variety of deployment approaches. So you can really use the best hosting platform and the best CI/CD tooling for your use case. You can really go nuts in how you want to set this up. And finally, the repo is all open source. You can go to this URL today and see it all in action and